Good morning, ladies and gentlemen. Today we're going to be working on writing equivalent expressions by combining like terms. So our learning goal is right at the top here. Before we can do that, we are going to look at some vocabulary and review some vocabulary. Variable. A variable is a quantity that may change within the context of a mathematical problem or experiment. Typically, we use a single letter to represent a variable. Next is our coefficient. The coefficient is a number or a constant quantity placed before and multiplying the variable in an algebraic expression. And then last, we have our constant here. The constant is a number on its own that stands for a fixed number. So here we have our coefficients, right? 2, 5, and 9. We have the variables, A, B, and C. And at the end there, we have our constant, which is 100. Let's go to the next page. I introduced the vocabulary term last week. So here's our definition here. A term is either a single number or variable, or numbers and variables multiplied together. Terms are always separated by addition or subtraction signs. So let me highlight our different terms here. 5xy squared is a term. 3x is a term. 5y cubed is a term. And 3 is a term. So now that we have the definition of term, now we can look at what like terms are. Oops, go back to my square here. There we go. So like terms are terms whose variables and their exponents, such as the 2 and x squared, are the same. In other words, terms that are like each other. The coefficients can be different though. So here we have some examples. 2x and negative 7x, those are like terms. Negative 8x squared and 3x squared, those are like terms. 13xy and negative 7xy, those are like terms. And again, notice the variables are the same for each of those pairs that we're listing. The x and y appear in both 13xy and negative 7xy. The next one, 5x squared y and 3x squared y, both have the same variables, the x squared and the y together. Then the last one, x and 4x, both have an x in them, so they are like terms. Notice on the other side, unlike terms, the 2x, oops, let me use a highlighter instead. If you look at 2x and negative 7y, they both have different variables, the x and the y, so they are unlike terms. Negative 8x squared and 3x have different variables. One has x squared, the other has just x. 13xy and negative 7xz. xy is not the same as xz, so they are unlike. X squared y and xy squared. The variable is first on the x on the left-hand side and then on the right for the y squared. So those are unlike terms. And then x and 4, the 4 is missing, being multiplied with x, so those are unlike terms. So now that we know what like terms are, we can combine like terms, which means group them together to make equivalent expressions. So our instructions here say simplify, which means if we can combine like terms, we want to do that. So right away I'm looking at this 5x and the 13x. So I have 5x's, I'm going to add 13x's to it. That's going to give us 18x. Then we have a 9y over here, and we have minus y, which means we're going to take a y away from 9y. That means we'll end up with 8y. So we're going to add 8y. And we can't simplify it any further because the variables x and y are not the same. So that's the simplest terms that we can go to. All right, example number 2. I see we have a 3x squared. Let me use my highlighter. 3x squared and a minus 2x squared. Notice I'm circling the sign that goes before the 2x squared. That sign is important. That means I want to take 2x squared away from 3x squared. So that means we're left with 1x squared, or just x squared. You can put the 1 in front of the x squared. You don't have to, though. Then I'm going to look at the other variables. We have a plus 9x and a minus 8x. So 9 minus 8 would give us 1x, which is also the same as x. So I'm going to add an x to it. And again, these two terms are not like terms, so I can't combine it any further. One has an x squared and the other is just x. Okay, let's take a look at question number 3. I notice we have some parentheses here. We cannot combine like terms because order of operations would tell us to simplify inside the parentheses first. So to get rid of the parentheses so we can combine, we have to use the distributive property. So my first step is to multiply the 5 times the 2x, which gives us 10x. And 5 times 12 is 60. And then over here, 2 times 3x would be 6x. And 2 times 10 would be 20. So that's minus 20. Now we can combine like terms. I notice we have a 10x here and a plus 6x over here. So that's going to give us 16x. And we have a plus 60 and a minus 20, so that would give us plus 40. And again, I can't combine the 16 and the 40 because the 16 has an x attached to it and the 40 does not. All right, our last example, number 4. Again, I see these parentheses here. We have to get rid of those by using the distributive property. So we're going to multiply 6 times p and 6 times 2. Before that, I'm going to bring everything else down. So we have 12 plus 13p plus 6p minus 12. And then let's see if we can combine. I see we have a 13p plus 6p, that's 19p. And we have a 12 minus 12. So those two are actually going to get rid of each other because 12 minus 12 is 0. So we end up with just 19p. All right, I'm hoping to figure out how we can get onto a conference call together. If you have any questions, I will send some more information out shortly. And please also find attached a worksheet for some extra practice with combining like terms. I will post the answer key up as well. All right, hope you're all having a good day. Talk to you soon. Bye.